Okay, we finished most of the organic chemistry, and we are about to explain one of the toughest parts of organic chemistry. I'm sorry, but it's hard. Anyways, I'll try to make it simple. So polymers. Let me ask you a question. Did pharaohs have plastics?
No.
They didn't have plastics. They didn't have plastics. Why?
No. Because it's advanced.
Advanced. What do you mean by advanced? Humans discovered plastics some late in the 20th century. So in 1932, some guy, I can't remember his name, he's a scientist, I can't remember his name, discovered plastics. So that's why, therefore, pharaohs had no plastics. ما كانش عندهم مية نسلة. القدماء المصريين ما كانش عندهم مية نسلة. Anyways. So, what are plastics? Or most of the plastics that we see.
Polymers.
They are polymers. But what are polymers?
It's a group of...
It's not a family of organic compounds. But anyways, it's made from organic compounds. So polymers, which are plastics, or some of the plastics are polymers. But polymers is, I think, their scope is larger than plastics. So is made from how does we convert organic compounds to polymers? That's a very good question. So how? Very simply, something called polymerization. Okay, converts organic compounds
into polymers.
Into polymers. Okay, so are plastics organic compounds?
Yes.
No, they're different. They're not organic compounds.
But they're made of organic compounds.
But I don't think that they're organic. They don't have the characteristics of organic compounds. Or despite the fact that they are made from organic compounds, that's another different story. But anyways, so organic compounds undergo polymerization to give us polymers. So let's talk about the very simplest polymerization process. It's called addition polymerization. So first, addition polymerization. So by the word addition, it's basically you add something to another thing, something to another thing. So where in the organic history did we some sort of add things to each other?
Alkenes.
Alkenes. Remember the double bond? We open the double bond. So alkenes. Very good. Alkenes. So for example, we have ethene. Okay. We can add another ethene to it, right?
Yes.
But it's not an organic reaction. It's a different story. But basically, we can add two ethenes. But we can add million ethenes, right? Or, for example, 10,000 ethenes to each other, right?
Yes.
So we make it like that. C. Notice that the bond doesn't have an angle, right? There is no angle here. No angle. Okay? This is double bond. We have N ethenes. Like N can be 100, can be 1,000. Okay? These N combine. How do they combine? This double bond just opens. It breaks. And And here comes the N again. The double bond basically opens. That, of course, requires what? Heat. Heat. Okay? This is polymerization in very, very simple means. So this is called what? Ethene, right?
Mhm.
What is that called?
Ethane.
No. ما
Polymer.
تفعليش المرارة. Polyethene.
Polyethane.
This is polyethene. Polyethene. Ethene. With an E, not an A, okay?
Polyethene.
Ethene. Okay? Not ethane. Okay? Polyethene. So we got ethene. It gives me polyethene. And of course we need heat. Ethene is called a monomer. Okay? Polyethene is called what? Polymer. Okay? So ethene is a monomer. Polyethene is
A polymer.
a polymer. Very good. Okay, let's take a harder one. We want to combine butene. How can we combine butene?
We're going to break the double bond.
Okay, let's direct the double bond. But how? We have here. Oh, sorry, I drew it wrongly. Okay. Where will the other butene go? Where shall the new butene go? It's tricky.
It'll also be broken.
This one will be broken. So the double bond, so it will go somewhere here, right? Okay. But we will combine all of these. How many hydrogens are there? H2 5. And how many carbons?
2.
2. So can we write butene as follows? C.
2.
Let me. Minute.
So break it up to make 2 ethenes.
No. Can write it like that? We just combine these into a C2H5.
Yes, we can write it like that.
We can write it like that, right?
Mm-hmm.
So very good. This is, it looks like what? Ethane. Ethene, sorry. It looks like ethene. So can we combine 2 of these?
Yes.
Yes. How can I do it? Just N. Give me N.
Without the double bond.
H.
Polybutene.
Don't draw H's here. Okay.
Will it be polybutene?
1 minute.
Butene.
CH3. There are no H's here. Okay. No H's here. Just draw this line.
So other carbons will
No H's.
bond.
Because it has another
bond.
bond to a carbon. Okay. There's no H's. Okay. So this is not CH3. This is C2H5. Let me draw it clearly. C2H5. This is called butene. And this is called what?
Polybutene.
Polybutene. So, can you define what's a polymer from what we said?
So it's a It's a large. It's something big that has a lot of monomers.
Okay, so it's a large molecule built from
Monomer.
smaller molecules called
Monomers.
monomers. Take care, this is one, but in fact, this is one polyethene. In fact, I think I can copy it. Give an example. Oh, this is. Let me. Selector. Copy. It's something like this. Something like this, and it goes on. Okay, it repeats n for can erase.
But it's not infinite.
It's not infinite, but it's a lot of chains, very long, very long. Okay, this is called the repeat unit. Repeat
Unit.
unit. Okay. What else? So we touched upon plastics. So let's talk further about plastics. Plastics. So after you drink the bottle of water, where does it go?
The garbage.
Garbage. So number one. It goes to the garbage. What else? What happens after it goes to the garbage? To this plastic? To any water bottle. What happens?
Nothing.
Nothing.
It's thrown to the ocean, but it
So
doesn't.
basically, it doesn't change by
Yes.
time. It stays as it is. So, example, how many water bottles are produced each year? Like trillions of water bottles. So where do they go?
The ocean.
Not necessarily. So plastics have environmental problem of their disposal. Disposal of plastics harms the environment. So where does it usually end up going? Two places. Landfills. They dig holes inside lands and put the plastics in it. Or oceans.
Or sometimes they're burnt.
Okay, but even if they burn, I'll that's coming. But when they are put in ocean, what happens? They harm aquatic life. They can even kill fish. What's the plural of fish?
Fish.
Fish. Okay, no fishes. Anyways, they harm aquatic life. For example, some fish might be swimming and find a very large. It might kill fish. It kills fish actually. It doesn't. So it harms aquatic life. So and landfills, we don't have space. They get used up. So what is the solution for that?
Recycling.
So solutions. Before recycling, you said we can burn them, right? Burn plastics. However, that produces toxic gases. It's not very good. We can recycle plastics. However, not all plastics are recyclable. we can have something called biodegradable plastics. Bio.
Degradable plastics.
So basically, they degrade. So we can have something like ultraviolet plastic, ultraviolet degradable plastics. Let me check. Photodegradable. Sorry, photodegradable plastics. So they degrade by sunlight. Photodegradable
Plastics.
plastics. The other thing we can have, uh, we can have
Plastics that dissolve in water.
for example, plastics that dissolve in water. Okay, plastic. Let me get a cream. This is used in detergents, by the way. You put the detergent in the inside the washing machine with the plastic
On it.
with the plastic sort of covering, and it dissolves inside water. So also, some plastics are dissolved by by certain bacteria. So it's biodegradable plastics. Oh, biodegradable plastics. Biodegradable plastics. By bacteria. Okay, we finished most of the polymers, the basic polymers called addition polymers. And lastly, about plastics, despite having biodegradable plastics, the vast majority of plastics produced are non-biodegradable. Okay. Okay, so in a nutshell, we discussed polymers. We discussed the first type of polymers, addition polymers. Right?
Yes.
And we said these are the building blocks of plastics. Okay. In the next video, we will be discussing other types of polymers, basically under the umbrella of condensation polymers. See you in